Okay. Not many students this evening. They're coming. There are a couple of special, I think some of you already know, announcement. Yeah, we had last week very, very useful and informative events. Too short. So follow-up event already has been scheduled December 8th and 9th, which is a Thursday and Friday. That is the second week of December. So we have about 30, 35 days, and 5 weeks. From what we will do at that time, they're going to bring the technical team. One of them may be our graduates. If anybody from our program currently working at NSA visit us, that is really, really good. So you may hear some story behind, right, what's going on and in what way you can get in effectively. Those who really wants to join NSA. Basic requirement for NSA employment is, of course, U.S. citizen, and eventually you need to get top secret clearance. So which means should be born in U.S., I believe, and all direct blood relatives should be also U.S. citizen. Maybe there may be some a little bit of flexibilities. Yeah. But
it's not all blood. I don't know if it's all blood relatives, but I think you mean immediate family, like your mother.
Immediate,
father.
yeah, immediate, yeah.
Your mother and father should be citizens.
Mother, father.
Citizens or working?
No, citizen only. Yeah. Individual should be born here, and then direct family should be U.S. citizen.
That's
something
NSA
like that.
Or FBI too?
FBI is a little different. FBI is a little less restricted than NSA, because FBI has so many different levels of positions available. So it's not really like that. But NSA, 100% employees should be should pass that requirements. So those who are interested in, please prepare what they are looking for. They're going to accept a resume on that day, December 8th and 9th. But they want to also see if you have some hands-on skills. If you do not have right now, but want to build so that successfully join the NSA, can start and prepare something from this point. You still can make something, okay? So don't be discouraged, but I can help you and you can help each other. For example, since you are taking this course, what I want you to do is to make real meaningful project completion. Okay, I'm going to post the requirement of the proposal of your project. It is a group project, right? So you better form a group. Would be great if you can find someone that you want to work with, so that you need to put full efforts on the completion of your project. I will be available to give you comments, constructive comments, if you really want to join NSA with the project that you want to do in this class, okay? So that I can guide you to tweak. You can first propose your work. Then I can judge, oh, this is worth so that you can pursue. And I can judge, oh, this is the level of NSA interest. Okay? So, better to make a good group. It would be great all the group members are interested in NSA positions. Okay? If there is anyone who is not interested, then the characteristics of the project is not necessarily NSA target, NSA focus, or cybersecurity focus, right? So you need to talk to each other among yourselves and find out the collaborator and form a group. And if you have any idea, then you can come and see me. Then I can guide you. Unlike the past, NSA now are interested in only the following limited disciplines. Till 2 or 3 years ago, they opened up the employment to all disciplines, from English to foreign languages and psychology and all areas. Okay, pure science. But now they are still interested in all disciplines, but they want to hire more from the following disciplines. First of all, electrical engineering, but not other engineering, not mechanical engineering, not civil engineering. They used to consider all engineering, but not right now. Science, they are interested in computer science, okay, computer science. And real science, they are interested in mathematics. So, and also cybersecurity, of course. So all the disciplines in our departments are their interest. Okay. So, for example, this subject, data mining. Data mining is one of proven technologies of artificial intelligence that we can apply to cyber security, right? So you need to first consider the domain knowledge of cyber security. Okay, you need to be first expert in cyber security and find out which ones critical in defending or offending. Okay. They are now talking offend, attack more frequently than before. You know what? The best defense is the best attack, offend, right? So they want somebody who can attack. All right.
How can we know how to attack if we don't try it before, for example? But I mean, if we tried it before, FBI or NSA had not been accepted because we break the law. That's what
there are a lot of ways.
In the speech, he was like, think about your choice, what you do now, because basically they know if we did something wrong. If we hacked something, for example.
There are many. If you're talking about only their network only, then yeah, of course they protect it tightly and secured, right? But the digital asset is not only network itself. It has so many other and more important assets that we want to protect, right? So it's not really necessarily infrastructure attack only. There are so many others available. And hi. So NSA team says also NSA also a team that trying to attack, okay, in a way that other governmental organizations wants to see how secure their systems are. Then they request the NSA, hey, can you attack us? But by the way, they don't do that officially. But if there's something happens, then they want to be involved in to see there is any security holes. But anyway, so attack is not only in one way. There are so many different ways that are interested in. For example, software attack, not hardware attack. That is very, very important, right? Software program attack or software data attack, or through the computer systems which further into the physical plants attack. So all kinds of scenarios available. So you can think in many ways. Or direct attack is also possible, right? But this class is to trying to see how intelligently that we can attack. Or can we make any program that can intelligently respond to attack or response to defense, things like that. If you know some knowledge, some expertise, then we can use the expertise, human expertise, to defend or to attack. That is all the type of artificial intelligence. New type is we need to apply machine learning technology to that domain, which means expertise should be built by your program. Okay, it's not just a human expertise, but the expertise that can be learned from your computer. Okay. One of the technique is association rules, right? By looking at all the data in columns and rows, how can we combine them so that we may have more meaningful patterns? If there are meaningful patterns that may occur more frequently than we expect, then based upon those patterns, we can form a rule. Okay. So today we will do. We'll look at basically three things. Okay. We're not going to learn new concepts tonight. This is sort of tech nights. Okay. So we will do three things, basically. Download some executable association rule minor and practice it. Number one. Number two, we will do, there's a very useful data analytics tools available, right? One of them is R Studio. So using R, there are also a few modules developed. So we're going to install the module already built by someone else and practice it. Okay? And third, exercise is to do that in Python. Okay? And there is also some Python modules already developed by someone, so we can install that module and practice it. And finally, there is also a Python that I showed to you, implemented. It needs a lot of improvement, but that's what I demonstrated last week. Right? So we'll do a hands-on exercise today. And also when you already download this. If you download this, this needs, I think, some license, right? So those who wants to buy it, but I do not have. I'm just letting you know. Oh, for this is not really. I'm not sure. This does. We're not going to work on Excel. Reason not using Excel for data mining is because Excel has a lot of restriction, right? Excel does not contain big data, for example. Excel has a limited. If you have data on Excel, then processing is so slow. Extremely slow. Why? Data should be write and read back and forth, which is the big killer. So it is not really good way that you can do data mining. But if you have small data, then that is okay. Small data means 100,000 data sets or 10,000 data sets. There are small data sets that can be loaded within your Excel, and also you can exercise some more from there. That may be okay. Okay. So what we will do is this tool, a priori tools. So I want you to download something for Windows, okay? This. So that is executable. Okay, there's a tutorial. If you want to learn, we're not going to learn any in detail today. If we do, then even one tool, we cannot learn even one tool in one session. It takes a semester, right? But I want you to read. If you want to use these executable files, then you can visit that tutorial and get some training so that you can learn it more and more. Did you ask a question?
Yes. Which tool should we download now?
I want you to download this.
Is it free, or we have to put the code and buy it?
This is free, so you can download it. Yeah, from here, get downloaded.
We're going to be working today with that.
Hmm?
We're going to be working today with that tool.
Yeah, we're going to do it quick.
Is this a command line application? CLI?
Yeah, it is.
Okay,
So you download and then you can see, go to place where there is, yeah. This is a program. When you, hold on, let me show you what I did. Card. And to bring this here, and then I downloaded it, right? Can you see any A file? Yeah, this is a program. That's executable file. So this is the program. This application, A priori. There are so many A priorities, but the others are something else. Some of them will be discussed later. But that is that. So what you need to do is bring up command line windows. Command line windows like this. This is I'm going to a little bigger. Okay. What should I do? Probably I need to. So that I can see. This is better. All right. It's not really big enough, right? Even to me. Or about 24. I'm worrying about if it exceeds the margin. Right at the margin. Okay. No bigger than this. If I make bigger than this, then you don't see whole screen. Okay, this is the one that I want to go to. Is this a priori? Okay. So CD download and if I so many exe files. Yeah, only a priori.exe that is available. That is the application program that we want to execute. Example for that is I downloaded also. If you can see that on the tutorial. The one that I want to play with you is a program called task code. If I open this task code, This is a CSV file, comma separated value, which is created by Excel. So as you can see there's a basketball, no, not basketball, market, grocery basket example, right? What I'm going to do, I'm going to make it available for you to download from the Blackboard, okay? So that you can download it. Don't create it, but download it. I need to post so many things to upload, so you can download it from there. Mercy, blackboard.com. .520. Okay. This is a slide and more. Can I post it here? Okay, let's try. Items. Because I will have so many files to be posted. If I post it as a file, then you have so long list in that folder. So I'm going to make it in one separate item, and I would say data files for a priori. A priori is nothing but association rules. So here, I believe there is some attachment, right? This is an attachment. Okay, so browse my computer, which is downloads here, and I'm going to task cover. Simply submit. Okay, task file there. I'm going to post more that we want to. Let's see. I hope you download that API programs, right? While I'm doing. In this way, you and I can get the same speed while reading. Okay, I'm going to post all of this. Can I do all? No. Only one at a time. So what I will do is test the CBS. Name. And each one of this will be clickable so that you can download it. It's another format of data that you need to include into your all studio. That's what we want to practice here. All different kinds of data formats. This is another format. And that is also. Okay, so we'll come back to post if you need more. Okay. All right. So what you will have here at the end, there's a data file for a priorities. So this is one file that you can download, and there are many others as well. So for this practice, we want this task code CSV. The best way that you can put that on in the download, if you have the command a priori.exe files and the data file in the same directory, same folder, easier to run, right? It's not necessarily, but if you place your executable files and data file into two different directories, then you have to specify where it is, right? If you are familiar with the path expression, I would ask you to do that. If you do not know path expression well, in command line, put the executable files and data file together in the same directory, like I do have here. In this directory, downloads directory, I have a priori.exe file. Make sure that you have that. And also data file like test code. Test code, I have test code.cbs, test code2.cbs, test code 2.cbs. Test code.cbs is the file that you can get from the Blackboard, okay? So if you have that, then we can run a priori. That is the command. That is a program that we downloaded, right? That is an executable file. We do not know what language is used to implement that, but that is already implemented. That is a binary file. The many other programs that we want to practice after this, we have source code. For example, R and Python, so you can learn something from there. In this case, there's no way that you can learn unless you do. You can hack into that binary code. Okay. There's some other technique that you can learn. Okay, a priori, and then file name test code .csv. Okay, and hit enter. Then you can see.
You have to download that too? Where do we find that? A priori to test code.
A priori is.
No, I downloaded it. I run that, but the test code CSV, where do we find that? On the Blackboard?
Yeah, that's what I worked so far, right? Last 10 minutes.
No, I know.
I posted it.
Oh, it's there. I saw
Yeah,
it.
I posted it
Okay.
just a minute ago. Yeah, you can download it. Remember that I asked you to download in the same folder, unless you know for sure the proper path expression where your data file located. Right. If you see that, then it says reading task code 6 items. I'm not sure if it has 6 items. 6 items means apple, beer, rice, chicken, whatever that, milk, mango. I think 6 items, right? 6 items are read, and 8 transactions. So we have 8 baskets done. Building transactions, 13 node done. We do not know what it means yet. And then checking subset, subsize 1, 2, 3 done. Writing null, not writing null. Therefore, we want to write. If we want to write, then you can do here. The next parameter that we can add is the output. So you can say apra.out, apra2.out. How about that? That is the output file. Whatever the patterns learned by that program is stored in that output files, so that, see here, writing on that apl2.out previously is null because we didn't give it, right? And then 26 sets done. All right, sounds like it ran successfully. So this gives us some operational statistics. This is not the result of your data mining. We need to open up the output file. Output file is apri2.out, right? How can you open it? I can say notepad apri2.out. Then we can see the notepad. Okay, this is the pattern that we learned from that basket examples. Let me explain what it means. Mango 25. Mango, this is a data item, right? 25 means that is a support in percent, which means 25%. Every one mango every 4. One mango every 4. So which means there should be 2 baskets containing mangoes. Is it? Oh yeah, 2 baskets. Mango here and mango there, right? 2 baskets. We can take a look at this. And mango and apple together, there's association. Mango and apple together, it appears 12.5, which means only 1 basket contains both of those. So it tells you, but if you see some interesting case, chicken, rice, beer all together appears 25% of transactions. That's what it is, 25%, which appears more often. For example, rice and beer, every other transactions contains rice and beer, 50%. Okay? So this is a good implementation that you can use if you do not want to implement association rules by yourself, but to use possible this. If you use this, for example, for your project, then it's not worth to apply. It's not. Don't use this for any interviews. They may not be interested in. This is just running, right? Running the program built by someone else. You need to do, if you can add some values on top of this, then that is great, okay? But only problem in this case is that this is a complete executable files, so that you cannot add more onto that executable files. There is only one drawback. But for the project of for this course, if you want, you can use this. But I want you to, if you want to use this program, for example, then I want you to have more bigger data sets, and which you can interpret well. For example, there are a lot of websites available. I gave to you a couple of earlier in the earlier slides. For example, New York State has. New York is the only state that published so many data from various different organizations, from police department to city halls, all kinds, right? So you can download, and some of them provide API also, which means you can download it automatically, periodically, whenever they update, can be downloaded into your system. That is also possible. You can implement that on your iPhone apps. Interesting, right? And you can sell it. Any question about this a priori?
Can you open it up for the online students?
Good question. Great question. Okay, let's go. Give me 1 second. Let me see. Where is, yeah, here. So I need to go to another. Yeah, I do usually, but not like real time. But I didn't know that we have online students here in face-to-face classroom. In this way, I may not forget, right? Sometimes I complete for on-site website, but not online website, vice versa, which is not good. Here. I think, yeah, I posted that. Only the problem here is it's not really, I cannot copy that to this, crossover other courses. What was data, what did I say? Data files for April. Okay, that is good. And here, okay, first I need to go to downloads and Tesco. By the way, Tesco, is it Tesco the supermarket that you can find in London? Is it Tesco?
I think that's what it is, yeah. I haven't been there, but like...
Yeah, I've been there. I thought that is the same name, Tesco. Like here, what is it here?
Tesco, supermarket in England.
Yeah, that's what I thought. Yeah. Did I do this? Just I can think. 1, 2, 3, 4. 1, 2, 3, 4. I didn't do this. Okay, I think it is available. 1, 2, 3, 4, 5, 6, 7 files. Need to make sure that we have. Oh, that's okay. All right. So I need to minimize this. Another way, if you want to put, for example, oh, I do not want, not this. I do not want to collect any the item sets, but those item sets satisfies the minimum supports. Minimum supports. For example, support that is for S, negative S. And then if I want to see at least 30%, and then a priori 2 that out, then I might have smaller number sets, right? So only any patterns above 30%. That's what I specified here, right? Minus S 30. Therefore, anything contained in that output file satisfies that, right? So milk and beer, apple and beer, rice and beer. Oh, beer is popular. As far as there's a beer, everybody wants. Is it London citizens' favorite?
If I have beer, then it rained today. Something like that.
If there is a rain, then there are beers. So all the time beers. Okay. So you can catch up as you wish. All right. Now, so there are a lot of application programs, some free, some paid, available. So you can use it, but that's not the major focus that we need to do in this class, right? I wanted to do a little bit of underlying manipulation. Would it be great if you can implement? Okay. Two things. If you want to apply this for, and by therefore wants to look for a job, for example, federal positions at NSA, then you can build some of the association rule mining, or another thing that we are going to learn, two more major mining algorithms that we are going to learn is classification and clusterings. Okay, we're going to learn one by one. For classification also, either disassociation rule mining, and therefore implementation, or classification, or clustering for cybersecurity related data sets. And therefore, whatever the pattern that you learn from there, if meaningful and useful, then you can, if it is really useful and meaningful, then you don't need to join NSA, but you can sell it to NSA. So less likely, but if they are interested in, then you can be hired by them, and all different spectrums. So what we will do here, we need to learn some techniques in R. Okay. So next few slides, see here basic 1 and basic 2, 3. Let me give you a little bit of examples. This is concatenate numbers or combined. See, where? Oh, here. Where's my pen? Okay, here. This is for C for concatenate or combined. Everyone's talking about different. So anyway, that is C. It's a function C. This function C is an n-ary function, n-ary, which means it can take as many specified as possible. It's not just a binary, which it takes 2 parameters only, or unary, which takes 1 parameter only, but as many as you specify. Okay, that is possible. That's what we. In that way, you can create a file. And then another one here is a sequence. This is similar to the language in Python. That can generate a series of numbers. Anyone can tell what is the language in Python? If I have sequence seq takes 3 parameter, this is the number, this is a number to start. Second parameter is a number to stop. And third parameter is the step, by 2, by 3, or by 1. What is the language in Python? In Python, it is called the range. Okay. In R, it's called the sequence. That's what we are doing. Another one here is that we want to create a matrix. What matrix means is that you can create 2 rows and 3 columns, 2-dimensional spaces, like Excel spreadsheets. Okay, so it has columns and rows. Input file, as you can see here, a series of numbers, combined numbers. So you can enter as many numbers as you want, and then you can say that X, we call it X, and then that X is to be converted to a matrix in this structure. 2 rows and 3 columns. That's what we are going to do. Another way that you could do is, this is what I've tested those. Anybody here taking from me IASP 560?
I took it last year.
Your last year? Anybody currently? Okay. So we have chipset generations, which was not discussed the last year, but this year can be generated like this. Huh? Yeah, this is a chipset. Chip sequence is used to signal spreading out. So if you have sets of data, and for example, several senders together, then you collect them. You can collect as many sender data, and then put them in one signals, and then you spread them out. And at the receiver side, can be restored completely with no error, no dropping. The major point there is to generate chipsets. We can generate chipsets. This is not really for that generation. Has nothing to do with chipset generation, but to make a matrix, matrix, and matrix can be combined. Two matrices can be combined in column direction, which means horizontally, or can be combined vertically. We call it R-bind. Then apparently in this case, finally we have orthogonal chipsets. If you have orthogonal chipsets, then these chipsets can be used for spread spectrum wireless signals.
It can be used for
Spread spectrum. Yeah. Okay, another one is the basic 4. Not only the number, but symbols text can be used, right? For example, A is called here. A is nothing but the 3 words: mercy, college, cybersecurity. Another one is New York University. And then we can combine these two as a list. So list, you can say us equal A, U equal B. Then this F variable has this field, US field, which has mercy, college, cybersecurity. U field is a $U and $us. Therefore, if you say F $us, then it can bring this and vice versa. And if you want to find out even further, the first element of that component returns mercy. Or the subscript numbering system starts from 1, which is not the same as many other programming languages like Java, Python. Java and Python, the index starts from 0, right? But all it starts from 1. So that is a little different from others. And basic 5, we'll look at the frame. But anyway, okay, here. Oh, I have. Okay, here. For example, we can generate numbers from 1 to 3, like this, from 1 to 3. And I have another, the list, mercy, college, cybersecurity, horizontally. How can I two lists map each other so that frame contains A and number. A is a list, number is another list, but one in string, the other one in number, so that we have a good map. For example, mercy is 1 and college is 2 and so on and so forth. What is that? Map or hash in Java. In Python, it is called dictionary, right? How can we make a dictionary with the numbers if we want? There's no such things in Java, but in Python, that's called zip. We can zip two different values together. Okay, that is possible. But here in all, we call that data.frame. Okay, so those things will be discussed. And then with that basic skill sets, now we want to read the data. We want to scan file data. So various different kinds of ways of reading data. So up to this point, there's all. So what we will do, here, we don't need this, right? We do not need this either. But we need to practice using RStudio. So what I want you to do is to bring up RStudio. This is RStudio. Right? And we want to practice. From basic 1. Is there any way that we can increase the fonts? GUI preference. I have here GUI preference. I think we can size. I can increase the size, say 12. Okay. All right. So I have a bigger size. Okay. Let's combine the numbers in one variable. What is the language? What is all? That we can combine a series of numbers in one variable. And we can call that variable, say, x. I want to make variable x by combining, which is C, the following numbers. Any number that you want. So, for example, 2, 3, 5, as an example, 7, 9, 11, 15, and 21, and close parenthesis and enter. If you do not have any error, then it is okay. To verify, to see if that variable x contains the numbers that I combined, then you need to simply type x, then it returns, okay, I have those, right? And you need to understand what this means. We have here square bracket 1, which means the very next value is indexed by 1. So it is counted 1, 2, 3, 4, 5, 6, 7, 8. I entered 1, 2, 3, 4, 5, 6, 7, 8 numbers. So if you want to extract number 7, then what is the index that you need to say? There's a 1, 2, 3, 4. There's a fourth number. So if you want to extract that particular number, then within square bracket, x, and x followed by square bracket, with the index in it, then it returns number 7, right? You can further, with this series of numbers, it can be manipulated all together. For example, oh, I want to make x, I want to double each element of those numbers. Then x star 2, then that's multiplied by 2, right? So if you want to, oh, I want to save it into another variable, say y, then y an arrow, and then we can redo x times 2. And if you say y, then y returns 4, 6, 10, and whatever that, which doubled from the values in x list, right? We can do that also. Oh, I want to make either the arrow sign, or you can do equal sign. Doesn't matter. Many cases. I want to make exponents like square. Then you need to have double star. So x star star 2, then squared values of each element data in that list. Which list? List x, right? So z gives you 4, 6, 3 squared 3 is 9, and 5 times 5, 29, 25, 9, 7 times 7 is 49, 8, 11 times 11, 121, 15 times 20, 15 to 21, 21 times 21, 4, 41, right? You can also like this. I want to multiply x times z. What happens? Data by data. So y is number 4, z is number 4. So we multiply first element of the list multiplied by the first element in the second, in that order. So for example, 6 and 9, 6 times 9, then it's 54, right? 10 times 25 is 250. 15 times 49, 686. From this point, we cannot verify, but we trust, right? You can also generate automatically if you want to, for example, increase some numbers using sequence function. I want to increase from 1 to 100 sequentially. Then sec 1 comma 100, and then it gives you 100. As you see here, this is the index number 1. And this is the second, third, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why should I count? This is 22, 22nd, right? And then 23rd. So this index tells us the index that can reach this 23 number, right? So a series of those. So any number here can be accessed by the index as we make here. For example, if I want to access 97 directly from the list, this is the list of a whole number. If you want to access that, then what should we do? Here, I'm not sure if it works. I'm testing, okay. 97 may not work. This works in Python, but I'm not sure in R. Oh, all is also good language that we can see. What happens here is that this itself is nothing but entire this.
I want to access 97th element in this list. This is a list. 97th element is then by having that index number within square bracket, as we did here, right? Instead of saving this into variable and use that variable and index, I'm not going to assign that list into an extra variable, but simply use it. That is that, right? If I do it, for example, not the 19th, but let's make it 17 instead of 97, and I want to increase the numbers starting from 1 to 100 by 3. So first number is 1, 2, 3, 4. In that way, what is the 17th number? Oh, how did you? You're good. Oh, we have a mathematicians. So 49th, 17th. This is 23rd, 22nd, 21st, 20, 19, 18, 17. You are right, right? In our list, vector, array, they are all talking about same data structures. You know what I mean by that? See here, I'm going to write it here. List or vector or array, 3 different jargons. As you read any such in any manuals, they are talking about the same data structures. There's a series of data. List, then a series of data. Vector, there is also a series of data. Array, that is same thing. Okay? So vector, that is used in all so that we can ask, is the vector, is x, for example, x is above, right? Is x vector? Then you can say true. Okay. Y vector and others vector, but yeah, all vectors. Now let's make a matrix. Okay. In RStudio, if you want to clean up that Windows, in Python you can clean up. If you use Python editor, then you can simply type clear open parenthesis and close parenthesis, then the screen will be cleared. But in this case, this. What did I do? Control L. L for large, yeah. And you can clean up. Let's start. Again, X, and as we did in here, so 2, 3, 5, 7, 9, 11, 15, 21, 22, 23, 27, 29, 31, 33, 35, 37, 42.
Is there supposed to be a space between the 29 and the 31?
Doesn't matter.
Okay.
Like this. So what is x? X is this. Now we want to matrix. How many? Okay. There are actually, how many? How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18, right? 18. So, I want to make doesn't really matter, right? I want to make, doesn't really matter. I want to make matrix X and n row equal 2 and column equal 3, then 2 rows and 3 columns. Can I extend 2 rows and 4 columns like this, right? I have numbers 2, 3, 5, 7, 9, 11, 15, 21. I still have more, right? So if I have say 6 and 3, yeah. So all 18. 3 times 6, 18. So, I want to make 18, I want to include all 18 numbers in a matrix. So you can make another combinations, right? 3 columns, 3 rows and 6 columns, or 18. 9 rows and 2 columns, that is also possible, right? 9 rows and 2 columns. If you want to make, for example, I want to make 3 columns and 7 rows, which we do not have enough. No, 3 here, right? Then what happens? 7 rows and 3 columns. 7 rows and 3 columns. At least we need to have how many values? 21 values, but we have 18 values initially. So what is the error here? It says warning messages in matrix that data length 18 is not a sub-multiple or multiple of the number of rows 7, so which is insufficient, right? But if we have a smaller size of data matrix, possible, right? So we don't need to use all of them. But in grid way, if you want to make a bigger matrix for smaller data elements, then the kind of error. Okay, so what's the best ones that we can do? 3, 8, and 6. I want to make it I want to assign it to a variable, say y. So my y is this, right? It's y. How can I access, for example, I want to access 27. From that matrix, from that values in space, 2-dimensional spaces. How can I access a particular element, like in our spreadsheets, right? Excel programs. What is the index? Why? Within this square bracket, we need to make some index. See 27, if you go to here, then it says 2 comma, right? If you go to up, then comma 4. If you combine those two, then 2 comma 4, right? So 2 comma 4, then it gives me 27, right? This 27, here 2 comma, up here comma 4, combine those two, so 2 comma 4. So all is so kind.
So if you do only comma 4, it gives you all the...
Oh, that's good. Yeah. If you say in this square bracket, comma 4, then all the columns.
Yep.
Vice versa, number and comma, then all of those. Good points. We can generate, for example, from here, we can say y1, we want to split the matrix. For example, y oh forget about that. I'm not ready. Okay, so another one that I want to make with you is I want to make matrix and then column, say 1, 2, 3. So n row equal 3 and column equal 1. So that is enough, right? I want to make that in Z, right? So I have Z like that. Can I combine them? For example, horizontally. If I want to combine horizontally, then you can see column bind. So C bind. And I want to C bind Y and Z. Then there's a 7th column created. See here, I have this, but 7th column created, like this. That 7th column is the value that I entered here, 1, 2, 3. Vice versa, you can do all bind if you have same dimension of that, or less dimension. Then what happens? For example, U. Let's try. So U is, I want to redo here. Say that is U, and I want to make 1 row and 3 columns. So U is this. Can I combine this with that vertically? By the way, the command is all bind to see if it works.
Why is it all bind now?
C bind is bind along the columns. All bind is binding along the rows.
Okay.
The problem here is error in all bind because it's not the same dimension, right? If you want to combine this 1, 2, 3 to this 6 columns, then size-wise, it may be okay, but where it is not clear where we want to attach this 1, 2, 3. From the first column, or in the middle of the columns, or to the last columns. So it is not clear. So error. So don't try to do that. Okay. And others, you can practice. What we will do is we're going to make 20 minutes break. When you come back, we will do reading files from the external files that you can download from our Blackboard. So we will practice that, a few of those, and then a little more. Okay. All right. Let's take a break. By the way, next slide number 38. I want you to download the program called A Rules. That is going to be used for Studio. Okay, so you need to download it.
So go to slide 17.
Is that right? We'll do that together. The library and installation can be done in RStudio. So you don't need to do that separately. All right. It's because this is an extra recording. I forgot to record in my classroom. So this is continuation of that. Installation of the new the packages called A rule. A could be a priori, or A could be association. So there's a package, A rules, which gives you the capabilities of applying a priori rules or mining algorithms in order to install it. This is a very good way of installation that you could do. If I can make it bigger, so this is it. What happens here is that A rules, this is the package. If it is not, see here, so exclamation means if it is not, if there is no A rules package in this list, installed package, this is another function, and that is the list of installed packages. If it is not, then we want to install. So install the packages is a function, and another thing is install packages. This function takes the name of the package, and if this package requires any other packages, then we want to include the packages here. So any depends, so that install it, yes, true. Okay. This is just for one advanced version, so visualization. We do not need to do this. So once you do this, and then you can do this libraries. Right? So let's try. So I'm going to open up Paizo. Those who do not know Paizo, then you have to install it as we did it in the earlier class. You have to go back to do that, okay? Alright. So my system's a little slow. What I'm going to do is I'm going to copy this instead of okay. So here, oh wait a minute, this is Paizo. I'm sorry. We need to bring up R Studio. Okay. So Studio. Right here, Studio. So I can copy it. So it works well, right? And if I do library A rules, then it goes fine. What I will do is I'm going to download the file Titanic row from this website. Okay, this website gives you some data sets that you can use. So if I can go and you can download this Titanic.row.r data. Okay, so download it. Make sure that as you download, usually if you do not change it, the files downloaded from external sources will be downloaded in here in the downloads directory. Some of you, if you do not know where this downloads directory is, then it is actually right under the PC, but actually it can be accessed from your own directory. For example, this is a C drive, and there is a users and your name, and if you see there is a downloads. Okay, if we click this downloads, then look at this. This is the path that you can access the downloads, where there is all the files. One of the files that we look at is a Titanic.r row data in usually in R. So, but we do not know where our R studio is running. It should be in the same directory. Otherwise, you have to specify explicitly all the path to that file that you want to include in your R studio. So to find out that, what you can do is to get the working directory. There is a function called the get wd working directory. So we need to see where are we. We are right now under documents, not downloads. If you see here, then downloads is under JUN, which is on the users. So documents is the sibling to downloads, both documents and downloads have the parent directory called the JUN. So we need to, what we can get back to downloads directory is that we need to first go up to JUN and then come back to downloads directory, right? The way that you could do is you can do set WD. Here I would do dot dot. Dot dot means it's a parent directory, right? Parent directory means dot dot. Dot, single dot means my directory. Double dot means the parent directory. This is a symbolic notation that has been used widely, not only here in R, but in most cases. Windows operating systems, Linux operating systems, anything that you want where there is a system programs available, then they use this standard, right? So it works here also in our studio, luckily. So after I move back up to my parent, I want to see where I am. When I see the working directory, then I am now above my parent directory. And I need to go back to downloads. So download, set working directory to download, which is under JUN. There is no error, so that I can see where it is. Oops. Get WD. Then I am now in downloads, right? This is downloads. I was in documents. Here, if I want to see my files, there are a lot of files available, right? Titanic is one of those that you can see here. So Titanic. This is the file that I want to include. Okay. So let's try to do that. All right. So rules. What we could do is a priori Titanic dot row. If you do this, although you have that here, it doesn't look for the current directory. So it says file is not found. Although if I do the full name or data, it doesn't find the directory. Rather, what we need to do is we need to use load, and we have to do it full expression. Let me see if we could do full expression. For example, D column, or that is in C column backslash users backslash JUN backslash downloads backslash. Actually, I don't need this one. Let's see if it understands. Hopefully, but try. It doesn't understand that either. Let's see if it understands. This is the problem of this the module. This module that is written by someone else, right? It's not really well, it's up to the developers approach. So still a problem. So what the best way that you could do is bring up that. You simply bring this into this studio. Okay, then there's a load function. It takes all the expression. See, this expression is not taken, but load is the function provided by RStudio. A priori is a third-party function that we just installed. So it's a little different, right? So we loaded it. Once we load, then we can simply run this. A priori, tighten it. We don't actually need this. Simply that. It still works. See here it says algorithmic control, absolute minimum support count to 220 patterns satisfies that, and all of those, right? So rather than having this, if we save this to a variable called rules, how come is saved on that, and then we can see the rules. Okay, we can inspect rules, then we can see the rules of those. So one of the rules says the class, crew, and age is adult, then usually there's a male. What is how often it is the case? 40% of those. What is the accuracy? Almost all, 97% is the case. Let's look at the one above that. Crew and sex males, then they are all adult. It's 1.0. Confidence. And then support. This is the value for supportiveness. This is support value. This is confidence values. Okay, this is left hand side rules. This is right hand side rules. If this is true, left hand side, and then whatever in the right hand side is true. How often this rule can be applied? That tells us here the support. Once it is applied, is it how much is it is accurate? It accurates 95%, 98%, 100%, and so on and so forth. So it gives us some rules, right? Someone may ask, are all of these rules interesting? Are all of these rules the rules previously unknown? Maybe not, right? So there is another issue. Although we find some rules, those rules may be, oh, that's reasonable. And knowing that rule, what is the hack? What is the benefit of knowing that? For example, if there is a crew member and if that person adult, then usually male. Or more apparently, if there is a crew members and that crew member is a male, then of course adult, right? 100% confidence. Finding such rules is good, but are they useful? Well, there is another issue, right? So data mining techniques, if not tweaked to improve much. It gives you a set of all possible rules that algorithm can find. Whether or not those rules will be applied is totally up to the user, right? That's user's decision is to be involved. It would be great if this data miner gives us more than this, okay? Support, confidence, and some other measurement. For last couple of decades, a few of other measurements are also defined, but this primitive concepts is not doing that. So this is just a concept for you to start thinking about data mining. All right, so you can apply this, or you can implement further for your own in R. Expanding the knowledge and skills of R scripting on your own. Okay, so what we've learned so far, data mining tools that can run as an executable command file, so we use that, right? And two other things considered more. Within all Studio, you can program it to find out to implement the algorithm that you know, or algorithm that you invent, or you can download some packages already developed and use it as we just did, right? That is fine. So that is a second way that you can practice about association rule mining. And there are many ways, but in this class I'm going to give you the third way that we could do is to be in the language Python. Okay, so I want you to download the package called a priori. Okay, if you download it and install it separately, you could do that, right? And if you download this package and place it in one of your Python application program, Python engine located, and then there is called a library directory, and you can add this unzipped file there and find out setup.py, and then you can run this command Python, this is engine, and setup.py, this is a Python file, and then if you say install, then that could be installed. For example, in my case, my Python is in C drive, Python 36, and then there is a lib, and I unzip it. There's a priori, right? A priori, same as a priori. And if you open this, then there is a setup file. Okay, this is simply another Python program. This is a Python program. All right. And if you do this install, then it reach at this specific URL and download it and then install it. That's what it does here, right? So internally, you do not have to worry about it, but if you make this command, then it is installed. Or if you use a Paizo, then we simply do pip. It's a Pi installation program and install a priori. So what I'm going to do is I'm going to open up Paizo. Okay, so you do not need to you do not need to download. All right, simply pip install pip install and a priori. Enter, then it installed automatically. But in my case, it's already installed, right? No new version, so I'm okay. In order to see if it is really okay, then you need to see it from a priori import a priori. If there is no error, then it is installed, right? So it is installed. What we need to do is okay. I'm going to make a new here. So here you can try from a priori import a priori. So a priori is now available, and then transaction can be in within this bracket. Okay, so bracket means a list. So this trans variable contains a list of supermarket baskets. Each basket is within that another bracket. So if I have 5 baskets, and I have 5 baskets. Each basket I have some others, right? For example, beer and nuts. And another, I have beer and cheese. And another basket, I have wine and cheese. In another basket, I have wine, nuts, and cheese. And on the basket, I have cheese, wine, and beer. You can make as many as you want, right? This is the basket that I have. Once you have this, then you can run a priori rules applicable to trends, which is a list of supermarket baskets. Okay? And if you want to run, then I can highlight all and then hit enter, then it says, yeah, it is done, but there is nothing that I made a print. So can I do a print? And then hit enter, then it gives me, oh, this is an object of a priori result. So that, in order to see the list of the outcome, then I can say, I want to make it as a list. So I made a list. And then run. So that I have all of the rules that I just made. These are the rules that I made. That this program discovered and mined, right? Everything in the list, this is the outer list, okay? And that's this, that ends, that begins. This is too long list, so that we can, for example, copy this, and let's take a look at this in another notepad. See how it works. This is notepad. So there's no idea. It's not a good idea to put here. But anyway, let's see. Take one. This is beer and nuts. Let's take something else. Okay, wine and cheese. Cheese beer wine. I want to see. Record item for cheese, nuts, wine, support to, and order the statistics. Cheese, nuts, items add. Into this cheese, nuts, we had wine, therefore we have this cheese, nuts, wine. Confidence is 1.0. And another order the statistics. Choose wine, nuts. So somehow there's an association, and two or more items for example, cheese and nuts are also associated, and it tells us, hey, 20% of the transactions contains cheese and nuts together, and that's what it says. For example, here, cheese and nuts. Yeah, we have cheese and nuts here, right? Only in one basket out of 5. So there is 20% of support. There's another 60% support, which is wine and cheese. How many baskets has wine and cheese together? I think the last 3 here they have cheese and wine and cheese together. This module, this package tells us only the item sets with support and confidence and lib, whatever. But it doesn't construct a rule. But if you expand a little further from this, then the rules that I want to hear is that once the wine is picked up, then cheese always, right? If you have a wine picked up, then there is a cheese. It doesn't mean that if cheese picked up, wine always. No, it is not the case, because cheese picked up in the second basket, instead of wine, we have a beer. So it is not the case, right? If a wine picked up, then cheese. That's what I intended to make here. So this gives us association only, associated item sets. But we can make it further to generate association rules if you want, right? That is one advancement from this package called a priori. And then you can use other data sets. This is data sets that we looked at the last time, right? Tweets from today. If you want to, this one is like this. You have list of items in one line, okay? And the next line is another, let's say another basket or another line, and you have multiple lines. And this file may have about 1,000 lines there. How can this program, by the way, a priori, takes the input data within a square bracket, and each item sets should be in another square bracket, right? And another square bracket. That's what we practiced. So you have to convert this data to this format. This is trying to make it, as I said here, to construct a list of the lines. So one line of that file can be appended to the list called the rows. So rows is nothing but the list. I want to append. So read one line, and then I want to append it to one bracket. Second line, that will be the second bracket, and third bracket, fourth bracket. That's what I did here, right? Now once you have that, and this row will be fed to that program, a priori and rows. As we looked at, this is just an object. So we want to put it in the list format and then print it. So in this way, you can use the package a priori for any types of data. Once you massage the data, and therefore construct the data in the format that is accepted by this module, okay, module that we want to use. This is the tools that we downloaded, which is run on Python. Another way is that you can simply implement it. Implementation in Python. How? This is what I did actually. Here, finally, we have association role items. So qualifying association role items. This is a qualified item sets. And qualified item sets, which is it should support the minimum support threshold. Before we have this, we have all sets of associated items. That is here, associated items. And there are many paths up to this associated item sets. So a lot of different approaches that you can make this. The basic idea is that we already practiced that. This is the idea, right? So given, well, sometimes it's not given, right? Then you need to make this, and then consider each single item sets and with the supports. And if there is any doesn't meet the minimum support threshold, then that will be out. And then among this, you have to also associates. And of those associates, some of them are not realistic, some of them doesn't meet the minimum support, then we need to filter them out. And we'll continue to do that until we have no more item sets to be created or constructed. This is what we have done. All right. So hopefully you can make this one or more ways that we discussed in this lecture, right? From using executable files to the implementation in Python. So various different ways that you can practice. I hope this helps you and do some good works. Okay? Have a good day.